Hi everyone, this is Gayatri from CSC Data Science, and today my AAT concept video topic in BE is characteristics of DC series motor. First of all, what is a DC series motor? A series DC motor connects the armature and field windings in series with a common DC power source. The motor speed varies as a non-linear function of load torque and armature current. Current is common to both the stator and rotor, yielding current square. What is the working principle of DC series motor? What is DC series motor? DC motor is a motor which converts the direct current into the mechanical work. It works on the principle of Lorentz law, which states that the current carrying conductor placed in a magnetic and electrical field experience a force. Why is it called a DC series motor? A series-wound DC motor, like in the case of shunt-wound DC motor or compound wound DC motor, falls under the category of self-excited DC motors, and it gets its name from the fact that the field winding in this case is connected internally in series to the armature winding. What are the three types of DC motors? Main types of DC motors are permanent magnet DC motors. Permanent magnet motor uses a permanent magnet to create field flux. Series DC motors. In a series DC motor, the field is wound with a few turns of a large wire carrying the full armature current. Shunt DC motors. Speed current characteristics. In case of a DC series motor, the MMF due to the exciting coils increase in direct proportion to the line or armature current, so neglecting armature reaction effects. The value of flux varies with the load current according to the ordinary magnetization flux curve owing to the armature reaction. The actual curve representing the usual flux falls below the open circuit magnetization curve, as illustrated in the figure 1.18. With large currents, the magnetic circuits get saturated and flux tends to approach a constant value, as shown in the graph. Now take a look at the graph. From the speed equation, it is obvious that speed is proportional to back EMF Eb and inversely proportional to flux per pole. With the increase in armature current, voltage drop in armature circuit and series field of L of Ra plus Rc increased, and therefore back EMF Eb decreases, as shown in figure 1.18 in the previous slide. However, under normal conditions, Ra plus Rc, that is, R armature plus Rc, drop is quite small and may be neglected. Thus, if the applied voltage remains constant, speed n is inversely proportional to flux. If a curve is drawn between speed and input or line current I, it will be a rectangular hyperbola before magnetic saturation, as up to saturation point, the magnetization curve is a straight line. In this region, the speed decreases abruptly with the increase in input current. After magnetic saturation, the flux phi tends to become constant and speed current characteristic becomes a straight line, and speed decreases slightly due to voltage drop in armature and series field, as shown in figure 1.8. The speed becomes zero when the input current is the normal short circuit current on the motor, that is, equal to applied voltage divided by the motor resistance. Normally, this current is many times full load value. From speed current characteristic, curve, it is obvious that the series motor is a variable speed motor. That is, speed varies with the variation in line current with the decrease in load on a DC series motor. The speed increases and may become dangerously high at very light loads. Since on no load the speed is dangerously high, the machine may get damaged due to heavy centrifugal forces set up in the rotating parts. This is a reason that series motors are never started on no load. To start a DC series motor, mechanical load is first put and then motor is started. Actually, what is the difference between DC and AC? The most basic difference is the power source. AC motors are powered from alternating current, while DC motors are powered from direct current, such as batteries, DC power supplies, or an AC to DC power converter. Alternating current is cheaper to generate and has fewer energy losses than direct current when transmitting electricity over long distances. Although for very long distances, more than 1000 kilometers, direct current can often be better. Why is DC series motor used to start heavy loads? The torque of DC motor is proportional to the field current and armature current. In the case of DC motor, the torque becomes square of the armature current. This is why the DC series motor is used for driving heavy loads. Since on no load the series motor attains dangerously high speed which causes heavy centrifugal force resulting in the damage of machine, series motors are not suitable for the services, where the load may be entirely removed and for driving by means of belts because mishap to the belt would cause the motor run on no load. The motors are suitable for gear drive because gears provide some load on account of the frictional resistance of the gear teeth in case of sudden release of load. However, very small series motor may be used with belts, since in case of mishap, to belt the comparatively large friction resistance would represent an appreciable load on it. The minimum load on a DC series motor should be great enough, not below 15% of full load, to keep the speed of the motor within limits. In case the speed becomes dangerously high, the motor must be disconnected from the supply main. Torque current characteristics. From the expression of mechanical torque T, it is obvious that torque is directly proportional to the product of flux per pole and armature current Ia. Up to saturation point, flux is proportional to field current and hence to the armature current, because Ia equal to If. Therefore, from light load mechanical torque, T is proportional to the square of the armature current. That is, T is directly proportional to Ia square, and hence curve drawn between torque and armature current up to saturation point is a parabola as shown in figure 1.18 in the previous slides. After saturation point, flux is almost independent of excitation current, and so the torque is proportional to the armature current. That is, T is directly proportional to the Ia, that is armature current. Hence, the characteristic becomes a straight line. The useful or shaft torque is, of course, less than the total or gross torque developed. This is due to torque lost in iron and friction and windage losses. After saturation point, flux phi is almost independent of excitation current, and so the torque is proportional to the armature current. That is, T is directly proportional to Ia. Hence, the characteristic becomes a straight line. The useful or shaft torque is, of course, less than the total gross torque developed. This is due to torque lost in iron and friction and windage losses. From torque current characteristic, it is evident that series motor develops large starting torque to accelerate the heavy masses, and from speed current characteristic, it is also evident that speed falls. As we know, DC circuit is not used in homes. What's the reason behind this? DC, that is direct current, is not used at home because for the same value of the voltage, DC is more lethal than AC since direct current does not go through zero. Electrolytic corrosion is more an issue with direct current, which like the DC series motor torque T can be proportional to the Ia square of the armature current. In load test on DC series motor, the motor should be activated on load condition because if the motor can be activated on no load, then it will achieve an extremely high speed. Speed torque characteristics. Which torque is of DC motor? In a DC motor, a circumferential force F at a distance r, which is the radius of the armature, is acted on each conductor tending to rotate the armature. The sum of the torques due to all the armature conductors is known as armature torque. Speed torque characteristic. For low values of load current, I directly proportional to phi and T equal to K3 phi square. Phi equal to root over T by K3. Substituting phi equal to T root over T by K3 in equation 1.28, we have N equal to K1 V by root over T by K3 minus K1 K3 by K2 into phi square RA by phi square, that equal to C1 by root over T minus D1, where C1 and D1 are two constants, that is, the shape of the speed torque characteristic will be hyperbolic. As shown in the figure 1.19, it is a hyperbolic graph. For large values of load current, phi remains almost constant and therefore speed will be given as n equal to C2 minus D2T, where C2 and D2 are constants for the machine, that is, speed torque characteristics will be linear in nature. Speed torque characteristic is also known as mechanical characteristic. Speed sharply falls with the increase in torque for smaller values of load, but at higher loads, speed drops linearly but slowly with increasing torque. Hence, series motors are best suited for services where the motor is directly coupled to the load, such as fans whose speed falls with the increase in load torque. Why does DC series motor have high starting torque? The armature current Ia flows through the field winding. Flux phi produced in the motor is very high. The torque T of the DC series motor is proportional to the square of the armature current. So, DC series motor has a high starting torque. What type of starting torque does a series motor have? However, in a series wound motor, the increased voltage causes both the armature and field current to increase. This allows the series motor to produce very high torque on startup for short durations. That is, operation of the motor at high torque, that is high current, for more than a few minutes can damage the coils. Which DC motor has the highest starting torque? The DC series motor is the best motor for high starting torque to drive high inertia loads. That is why DC series motor is used for driving heavy loads, contrary to the DC series motor. The starting torque of the DC shunt motor increases linearly with the armature current. Performance curves of a DC series motor. In figure 1.20 are shown in the slide. Four important characteristics of a DC series motor, namely torque, speed, current and efficiency, each plotted against useful output power are shown. From the performance curves for a DC series wound motor, it is noted that the speed of series motor falls rapidly with the increase in load. So, a series motor is not requiring a substantially constant speed. The efficiency increases rapidly in the beginning, reaches its maximum value and then decreases. This is due to the fact that our light loads, the friction and iron losses are large compared with the load, and effect of these losses becomes less with the increase in load. The armature and field copper loss varies as the square of the current. So, these losses increase rapidly with the increase in load. The efficiency becomes maximum when friction and iron losses are practically equal to the copper loss. Series motor develops a starting torque comparatively greater than that develops a shunt motor for a given current. Hence, series motors are best suited where huge starting torque is required, that is, for streetcars, trains, hoists, and locomotives. In addition to the large starting torque, there is another unique characteristic of series motors which makes them best suited for traction service. For instance, let the streetcar ascend a gradient. In case the shunt wound motor is used for driving the above streetcar, it will maintain the speed of the car at approximately the same value that it had on the level ground and therefore will tend to draw an excessive current. A series motor, on the other hand, automatically slows down on such a gradient because of increased current demand, and therefore it develops more torque at reduced speed. This drops in speed allows the motor to develop a large starting torque with but a moderate increase of power. Hence, under the same load conditions, the rating of a series motor would be less than for a shunt motor. Series DC motors are generally used where high starting torque is required and speed variations are possible. These types of direct connection motors are, for instance, used in the traction system, cranes, air compressors, vacuum cleaners, sewing machines, etc. Thank you.